Hi, this is Guru Report. You are 16 CS 127 and I'm here to do my 9th experiment on data structure implementation of hashing with collision resolution techniques. My objective is to implement hashing with collision resolution technique with the functions for insert, search and display. So this is my program code. Here this is my main function. I have given the choice, given output and the size of the hash table. So I have created a hash table using h of n with for loop I is equal to 0, I less than n, and I have incremented I, and I have already assigned all the value of h of I is equal to -1. So it will show the whether it is empty or not. So I have an in data I have value up here, given the output insert, display, research, for delete, file, exit in the option. My choice, then I have given the input for choice. I have used a switch case here to switch according to choice. So first, if you want to insert, it will call the function insert, then search, then display, then delete. So this is my function insert. Word insert, I have initialized given the parameters as data, h and n. I have initialized I as integer, position as integer, and I have given position is equal to data modulus of n. So the modulus of data will be position, and for that slot the data will be inserted. If h of position is equal to -1, h of the data will be assigned to h of position. Else, if it's not -1, I have given a for loop here for I is equal to position plus 1 modulus of n, I not equal to pos, I is equal to I plus 1 modulus of n. Here we are using modulus of n to circulate in the hash table. If h of I is equal to -1, then assign data is equal to h of I. If I is equal to position, the hash table is full. Our next function is search. I have given the parameter in data int h, int n. I have initialized p as integer, and p is equal to position is equal to data modulus of n. If h of p is equal to data, the element is found. If it's not the one, I is equal to p plus 1 modulus of data, I not is equal to p, and I is equal to 1 plus 1 modulus of n. If h of I is equal to data, the element is found at the element, else it is not found. The next function is display function. Let's see out the elements in the hash table are int of I less than n, I plus plus. If h of I is equal to -1, it will put the blank space, else it will print the function. And I have a delete function also. I have given the parameter delete, h and n, all are integer types. Initialize position as integer, p is equal to delete modulus of n. The element which you are gonna delete is entered, and if the modulus of n, if that is p, it will delete. It will store the value of h of p to a temporary value k. Then will assign the value of h of p as -1. The element is deleted. For else, if int is equal to I p plus 1 modulus of n, I not is equal to p, and I is equal to I plus 1 modulus of n. And if h of I is equal to delete, same as the above function, put the value of h of I to temporary value k, and h of I, assign the h of I value as -1. The element is deleted. The element is null. Let's run the program. Enter the size of the hash table, 5, insert, into the data is inserted is 4, then insert, and the is 8, again insert, and the data to be inserted is 6. Let's display that. It's 6, 8, blank, 6, blank, 8 and 4. Let's search for 8, element found at 3, yes, and then we can delete 8 as another element would be 8. Element 8 delete is element 8 has been deleted. Let's display that. It's 6, 4, 4 and 6, blank, blank and 3. So the program has been executed successfully.